listening to Worth Electronics What's Up, a radio podcast where each week we are seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and Worth Electronic technical specialists. We're going to shine a light on interesting topics such as energy harvesting, wireless power transfer, EMI issues, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Worth Electronics What's Up podcast. Well, today we are talking with an expert. Dean Humela is a senior manager with our product manager group, and he specializes in transformers. Now, as many people know, Worth Electronic has an outstanding custom team, and they have an extensive knowledge in magnetics, and this includes transformers and chokes, and also wireless power and data transfer. Dean has a lot of years under his belt, and we're happy to have him on the show to talk about current sense transformers. So, Dean, thank you for joining us today. Now, before we get going, can you tell us a little bit about yourself and your background?
Yeah, sure. I'm a double E by training, and I've been with Worth Electronics for almost 25 years now. And I'm part of the product management team here, a senior product manager, and we're responsible for really a lot of the power isolated products for the company.
Now, before we get into the technical aspects of the current sensors, can you give us a little background? What is a current sensor and where are they used?
Well, a current sensor is a device that detects the current flowing in a circuit and provides a signal to another part of the circuit in a form that allows the circuit to interpret the measured value of the current. And really, these current sensors, they're used pretty much everywhere. They can be found in anything from household appliances, computers, e-vehicles, to industrial applications such as smart grids and switching power supplies.
Can't a designer just use some advanced math? Why would a device want to know how much current is flowing in a circuit?
There are really many reasons. They're used to control devices such as motors used in fans and blowers, or any other imaginable application where a motor might be used, even on things like e-vehicles. They are also used to detect that current is even flowing. In other words, they can detect if something is turned on or not. Another use is to protect against overcurrents that can cause damage to circuitry. In particular, current sensors are often found in switching power supplies using current mode control. The current sensor measures the peak currents, thereby allowing the switch mode power supply controller to respond accordingly.
Does that mean that there are different types of these sensors, or is it a one-type-fits-all solution?
There are many different types of current sensors. Current sensors generally fall into three buckets or categories, as I would put them. There are shunt resistors, electromagnetic current transformers, and electronic type current transformers.
Can you describe some of these different types of categories, and why would you choose one type of current sensor over the other?
Well, a shunt resistor, these are typically very small and low cost. They also can measure both DC and AC current. The downside to shunt resistors is that they typically have larger power loss in high current applications, and the measured circuit cannot be electrically isolated from the measuring circuit. Current transformers, while not as small nor as inexpensive as a shunt resistors, are still quite small and relatively inexpensive, especially when comparing them to the electronic current transformer solutions, or the electronic current sensor solutions. The beauty of the current transformer is that they provide galvanic isolation, and the power dissipation is very low in comparison to shunt resistors. Another advantage of the current transformers is that they have a high output signal, which provides better noise immunity. I also should mention that the circuitry is very simple and it doesn't need an amplifier when using a current transformer. A disadvantage to the current transformers are that they can only detect an AC current and not a DC current. While if you look at now electronic current transformer modules or electronic current sensor modules is a better way to word it. They come in many types, such as Hall effect sensors, flux gate sensors, and even like fiber optic current sensors. These modules offer advantages for certain applications, such as weak field detection and measuring DC current. The downsides can be high cost of the module, size, and accuracy, all depending on the type that's chosen.
Okay, now you mentioned isolation of the circuitry a couple times just now. Why is this so important?
Isolation is important for a couple of reasons. First and foremost, it provides a means of protection to circuitry, equipment, and users. So we need to keep everybody and everything protected. In switch mode power supplies, the galvanic isolation also allows one to easily implement high side sensing of current.
Why would that high side current sensing be important?
Well, high side current sensing improves the overall function of a system by reducing the ground disturbances in the system. The high side sensor also allows detection of a load to ground fault type of condition.
Okay, Dean, at the beginning of our discussion, you mentioned that you've been in the industry and in the company for a number of years. So you know Worth Electronic inside and out. What type of current sensors does Worth Electronic offer?
Well, we have a couple of different part types. We have a very nice line of shunt resistors and also a growing number of options for high frequency current transformers. In the future, I could even envision electronic current sensors for those special applications that I mentioned, but right now we don't really have the electronic ones.
Are there any benefits of the current sensors that Worth Electronic offers over maybe some that are found on the market?
Yeah, there are definitely benefits to ours. We typically, on any of them we're trying to provide the best value to the customer. So what we want first and foremost is very reliable parts. Our parts are all AEC Q200 qualified, but also we want it to be a value part. So we're looking at keeping the size small. We're looking at keeping the performance up there and the cost in a good range, all with a very reliable part, and thereby providing a value to the customer that is very much above all others.
It is definitely that more than you expect attitude from Worth Electronic. So let's circle back to the different types of sensors that Worth Electronic offers. You mentioned earlier the high frequency, but what types of frequencies are we talking about here?
Yeah, this question is hard to answer because it really depends on many factors, including what current you are measuring and what accuracy you're trying to obtain with the sensor, and also the sense resistor or burden resistor. That also, and what power it needs to dissipate, that also affects it. So, if you need accurate measurements, then the frequency range you can use the current transformers in is narrower than if you're just detecting is there current there or not. So if you need a design where it can measure accurately, we're talking typically with our current series of current sense transformers, maybe in the 1 kilohertz to 1 megahertz range, depending on the part and the application. However, if you're just detecting if there's current or not, then you can go to even lower frequencies.
How much current can the current sense transformers from Worth Electronic actually handle?
Okay, now this again depends on the application and the environment. Our largest parts can handle up to 40 amps RMS with a maximum operating temperature of 125 C. However, it depends a bit on your ambient temperature. If you're running at a lower ambient temperature, the parts can handle more current than that, and even more than what they're rated to on the data sheet. So, and we provide curves to show that how you can, you're able to determine just how hard you can drive these parts.
Absolutely. Earlier, you mentioned isolation. How much isolation do the Worth Electronic current sense transformers have?
This depends on the series type or the size of the part in the series. The smaller series provide either 500 volts AC or 750 volts AC isolation, while the largest size provides 1500 volts AC isolation.
Are there other types of these current sense transformers other than the high frequency ones?
Yes, there are. There are the 50 to 60 hertz type of transformers used for measuring line power. We currently do not have any series in this frequency range, but they are on our roadmap. And we're actually working on a series like that right now.
Do we have a time of when those might be released?
They're scheduled for releasing in 2023.
That is great news. Now, what parameters do I need to know to actually choose a current sense transformer?
The parameters you need to choose a current sense transformer include things like the maximum current to be detected, the maximum voltage for the current signal or the signal you're going to sense, and then the operating frequency and duty cycle of the current signal. And also it's good to know the maximum power dissipation in the burden resistor.
So just how do I figure out which current sense transformer to use?
Okay, this is it's a fairly easy process, but there's some calculations, etc. It's a little more than I can get to in a podcast, but I'll say this much, that you need to determine the turns ratio, and you calculate the flux density or volt microsecond rating needed, and then you calculate the maximum error due to the magnetizing current. I can refer you to an article by George Slama called Improving Power Conversion with Miniature Current Transformers, and that can be found on the Power Electronics News website. So I'd refer you there, and there you can manually calculate these. It's not super difficult, but it's a process. Additionally, I'd like to mention that here at Worth Electronics, we have the Red Expert tool, and we are working on a module that will automate the selection of current transformers and make it very, very easy to select one. You just enter your design parameters, and the tool will do the rest.
You mentioned that tool. Is it already available? Is it on the roadmap? What are we talking about here?
Again, we are working on the tool, and the expected launch is to be sometimes in 2023. So along with our 50 to 60 hertz current sense transformer series.
All right, that is great to hear. Now, before we wrap things up, is there anything else that you would like to add about the Worth Electronic current sense transformers?
Not really. I would just like to, add, like I mentioned earlier, that all of our standard current sense transformers are qualified to AEC-Q 200. So these are very reliable parts.
Dean, thank you so much for joining us here in the studio. And thank you for listening to today's Worth Electronic What's Up podcast. You can find more information about the Worth Electronic Current Sense Transformer series and Red Expert by clicking on the link attached in this podcast, or visit Worth Electronic online at www.we-online.com. You're listening to Worth Electronics What's Up, a radio podcast where each week we are seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and Worth Electronic technical specialists. We're going to shine a light on our topics like energy harvesting, wireless power transfer, EMI issues, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Worth Electronics What's Up podcast.